Gravel is falling off a conveyor belt at a rate of 10 cubic feet per minute. This gravel forms a pile in the shape of a cone whose height and diameter are always equal. How fast will the height of the pile be increasing when it reaches 10 feet? The volume of this pile is increasing with respect to time, so let's call it dV dt. And the problem is asking us to find the rate at which the height is changing with respect to time, or dH dt, at the exact moment that it reaches 10 feet. Also, we know the height is always equal to the base diameter, which is also twice its radius, 2r. We can solve for r to get half the height, or h over 2. This is a related rates problem. To solve it, we need to establish some relationship between these variables. And since this pile is in the shape of a cone, we can use the cone's volume formula as that relationship. The volume of a cone is equal to 1/3 that of a cylinder with the same dimensions, which is pi times the radius squared times the height. And since we know the radius of this cone is always half the height, we can plug that in for r. Now let's clean this up. This is a relationship between the volume and the height. Let's differentiate both sides of this equation with respect to time. The left side is dV dt, and on the right, using the power rule, we get this, which simplifies to pi h squared over 4. And this is times dH dt because this is with respect to time. We already know dV dt is 10 cubic feet per minute. And we're evaluating this equation when the height is 10 feet. 10 squared is 100, and 100 over 4 is 25. Now divide both sides by 25 pi, and simplify to get 2 over 5 pi. We have finally found dH dt. This comes out to approximately 0.127. The units of change in volume were in cubic feet per minute, so the change in height is in linear feet per minute. So now we know, when the height of this pile of gravel reaches 10 feet, it'll be increasing at a rate of 0.127 feet per minute. By the way, on a different topic, the slack on this conveyor belt actually forms a mathematical curve called a catenary, and I demonstrate how to derive its equation in my other video called the catenary. Thanks again for watching, and have a great day.